Hi there, and welcome to another Papetti Math YouTube video tutorial where I'm going to be teaching you, yes, you, Algebra 1. And in this video, we're going to be looking at exercise number 2 on modeling systems of linear inequalities. So we have the sum of two integers, x and y, is more than 20. If you take the sum of x and 4 times y, the result is less than 50. So let's set up a system of inequalities with that small amount of information, but enough information to set up a system of linear inequalities, and then graph the system on the grid. So our first piece of information says the sum of x and y. Sum means to add x and y. It's going to be more than 20. And our second inequality here is going to be, if you take the sum of x and 4 times y, it's going to be less than 50. So we have two inequalities here, and we want to go ahead and we want to solve this system by graphing it. But before we could graph this, we need to isolate each inequality for y. So I'm going to do x plus y is greater than 20 over here, and I'll do x plus 4y is less than 50 over on here. So I'm going to subtract x from both sides over here, and I'll be left with y is greater than negative x plus 20. That one was fairly simple. This one I'll start off by subtracting x as well. I'll have 4y is less than negative x plus 50. And then I'll have to divide everything by 4. And I'll be left with y is less than, well, remember the coefficient is not negative, but negative 1. Negative 1 divided by 4 is going to be negative 1/4. And that's going to be x plus 50 divided by 4 is going to be 12.5. So we have two different equations here, and we want to determine an appropriate scale on our axes here. Let's see if we have 20 units to go up by, and we go up by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We're going to have definitely enough to go up by 1s, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So there we go. We're going up by 1s here, and we're going to be going up by 1s on the x-axis as well. All right, here we go. Let's graph this first one where we're going to have a y-intercept at 20, and it's going to have a slope of negative 1 over 1. So we're going to go down 1, right 1, over and over until we reach the last point that fits on our coordinate plane. So keep on graphing those points in that downward slope of negative 1 over 1 until you run out of room. Okay, which I just did. Now we want to connect those with a dashed line because it's not equal to, it's just greater than. So if it's not equal to, it gets a dashed line. And now we want to look at where we're going to shade it. We're going to shade it where y is greater than this line, and the y values are greater than this line up above it. So we're going to be shading upward. Nice straight perpendicular lines. So it's easiest to see our solution set once we graph our second inequality, which is going to be y is less than negative 1/4 x plus 12.5. So again, we have 12.5, and that's going to be somewhere in between here, but we don't want to guess where 12.5 is. So again, we're going to be going to our calculators here, and when you go to your calculator and you put this inequality in your table, you're going to graph the whole number of points that fit on your coordinate plane. So you might see that 12.5, yeah, it's a guess there, and you're going to be going down 1, right 4. You don't want points that are on the middle of a line because those are guessing points then. So what you do want is you want exact points, and you'll see your first exact point at 2, 12. So you could go ahead and graph 2, 12. You might even go backwards and see negative 2 since we have that point here, and 13. So we have negative 2, 13, 2, 12. And if you look at the 2 points between them, you see that you're going down 1 over 4. So we go down 1 over 4 more to get our next point. right there. And you can see that those 2 points that were guesses are going to fall in place with the rest of our line, but at least we know by graphing the whole number of points, those are the exact values. So again, go ahead and put this in y equals in your calculator, and then pull up a table of values so you could only graph the whole number values, or the integer values for that matter. So we'll go down one more over 4 more, 1, 2, 3, 4. We'll go down one over 1, 2, 3, 4. Down one right, 1, 2, 3, 4, and down one right, 1, 2, 3, 4. Now that you have all the points that fit on the plane, we're going to connect them with a nice straight dashed line, because again, we are not equal to here. We're just less than. And we're going to be shading this inequality down because y is less than. So let's go ahead and shade this thing downward. And then you'll start to see your overlapping solution set. And again, denote that solution set with a huge letter S for solution. And the last thing we want to do is we want to state one possible combination of integers that satisfy the constraints of the problem. So we want to pick any point, and I like to pick a safe point that's right smack in the middle. So I'm not picking anything too close to my boundary lines, which do not include the solution, by the way. So that's why I want to stay away from those. So I'm going to pick this point right here. Let's see what that point is. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, comma 1, 2, 3, 4. 19, comma 4 would be one possibility that satisfies my solution, because 19 plus 4 is greater than 20, and 19 plus 4 times 4 is less than 50. 19 plus 16 would give me 35, and that is less than 50. Any point that's in this solution set right here would satisfy both of those inequalities right there. So if this video was helpful for setting up a system of inequalities based on a riddle problem, graphing them, and determining an appropriate solution, give this video a thumbs up, and you're ready for exercise number 3.